Hi, good day everyone. So this is the continuation of our lecture on the first law of thermodynamics. So last time we talked about the definition of thermodynamics, thermodynamic processes, thermodynamic systems, and the work done by the system with changing volume. So now let's talk about internal energy. So internal energy is denoted by U. Okay? So it's an energy, so therefore the unit of this is in joule. Okay, again, internal energy is denoted by U. So the internal energy of a cup of coffee depends on just its thermodynamic states. When you say thermodynamic states, say how much water in ground coffee contains, so pila yung amount of coffee, of water, yung lasa ng kape, and what is its temperature. That's ang internal energy is depende anang imong mga thermodynamic states. But it does not depend on the history of how the coffee was prepared. Means na, the internal energy is not dependent on the thermodynamic path. Again, U is independent on the path taken. Kung asa ka mo, say for example, this is your state 1 and this is your state 2. So internal energy is wala ga base kung asa nga path siya niagi padulong gikan sa state 1 padulong sa state 2. So it is independent sa imong path. Unlike sa work, work is dependent on the path. So muna ito discuss last time. Si work kay depende sa kung asa ka moagi gikan sa state 1 padulong sa state 2. Also the heat dependent po ang imong heat on the path taken. But take note, internal energy is independent siya sa path. Sa thermodynamic path na imong i-take say from state 1 to state 2. Okay, so that's internal energy. So, naman sulti, naman discuss sa internal energy, naman discuss sa work, naman discuss sa Q. Now, we will find the relationship between these three. Okay, take note. Unsa ang relationship aning internal energy, o kaning work, o kaning heat. Unsa ang relationship aning tulo? Okay, so we have this first law of thermodynamics. So basically, first law of thermodynamics is siya ang nag-relate sa katong tulo ka quantity, the internal energy, the work, and the Q. So unsa nga equation ako makuha nga mag-relate aning tulo, that's first law of thermodynamics. Okay? So ingon sa first law, it says that the change in internal energy, change meaning this one, okay, the change in internal energy, meaning sa change, sa itong change gani, change na ko'y final minus initial state. Okay, take note, basta may kong change, meaning na ko'y final minus initial state. So when I say delta U, it means na this is final state, internal energy of the final state minus internal energy of the initial state. And the first law of thermodynamics says that the change in internal energy, kung mag-change yung internal energy, it is equal to the heat added to the system Q, okay, heat added to the system Q minus the work done by the system. And this is basically the first law of thermodynamics. It says that, ito, first law states that the change in internal energy must be equal to the heat added to the system minus work done by the system. Basically, first law is just the generalization of the conservation of energy. Notice in your mechanics, na kayo makuha ngayon sa mechanics, the conservation of energy, conservation of mechanical energy, for example, conservation of mechanical energy, it says that the change of the energy is equal to 0. So kaning energy nga akong ginamin is katong kinetic energy o kaning potential energy and so on. Sakto ba? This is conservation of mechanical energy. The change of energy. So energy based from here, energy final minus energy initial must be equal to 0. Ano ko kinetic energy final, kinetic energy initial, potential energy final, potential energy initial must be constant, must be equal to 0. So the first law of thermodynamics kay gidungagan nimo ang conservation of energy o heat Q o W. Okay? So instead nga delta energy equals 0, i-equate nimo siya into heat and i-equate nimo siya into work. And that is thermodynamics. So energy lang gyapon na, internal energy is energy lang man gyapon ano. So instead nga 0, constant mo ang change of energy, i-equate nimo sa nakagidungog na term for work added to the system or work done by the system and heat added to the system. So mo nang gitawag siya nga generalization of conservation of energy. Okay? So sa conservation of energy, kaya itong balik ko no. Sa conservation of energy natin gitawag nga work kinetic energy theorem. It says that work is equal to delta K. Okay? And then sa heat and temperature na po tayo tawag na U of the energy is equal to Q. Sakto ba? The energy is equal to Q, which is equal to MC delta T lang or like that. Okay? So ang first law is combination ni siya atong kaning sa work niya nga part, which is gi-relate nimo siya into energy, and ang energy is gi-relate nimo siya sa heat. Combining these two, you will get the first law of kinetic energy. The delta U is equal to Q minus W. So kanina itong timanan, the delta U is equal to Q minus W, which is the first law of thermodynamics. And we have to take note, manawingon ganyan, ano? Ang Q and W depend on the path chosen between states, but the delta U is independent of the path. So wala siya gadepende sa kung asa ka nga path niyagi. Yung internal energy, change in internal energy. If the changes are infinitesimal, we write the first law as this. Magamit na dun siya later. The du, the change of internal energy is equal to the change infinitesimally change of work and heat. Okay, so take note of that. Okay, in a thermodynamic process, the internal energy of U of a system may increase. So kano sa mo increase ang U, kano sa mo decrease, depende sa iyang state, no? Depende kung dako iyang final internal energy at sa final state o sa iyang initial state. In the system shown below, more heat is added to the system than the system does work. So the internal energy of the system increases. So positive imuhang change of internal energy. Sa kaninga system, for example, the work done is 100 by the system, tama ba? Kung ang arrow is padulong sa gawas, this is work done by the system, so therefore work is positive. Kung ang arrow niya is pasulod, then this is work done is negative. Take note of this. So this is work done on the system, kaning arrow pasulod, and ang paggawas ng arrow is work done by the system. So we know basta by the system it is plus, and on the system it is minus. And also the heat, which is equal to 150, this is positive because heat is ga-enter siya sa imong system. So positive imong heat. Kung gawas imong heat, then Q is negative. So suppose we have this problem, Q is added and work is done by the system, then the internal energy is equal to plus 50 joule. Ini ani is ang imong internal energy is increase. Increasing ang imong internal energy. So ngano man kay dako man kay ka og heat nga gi-add compare sa imong work nga gidan sa imong system. Mura siya og for example ikaw for example imong lawas ang thermodynamic system for example. So nag-add kag heat, for example nagkaon ka og daghan kayo. Okay, nagkaon ka dagan kayo around 150 joule of energy imong ikaon. Isulod sa imong lawas na energy. And then nag-workout ka pero gamay ra 100 joules lang. Compare sa imong ikaon nga 150, nag-exercise ka, okay? Ang imong system kay nag-work. Okay, ikaw may nag-work for example, na-exercise ka o ay mo exercise lang is only 100 joules of energy. So, by first law of thermodynamics, there is a change of internal energy. And that change of internal energy is positive. So, posibleng nga ni change imong internal, posibleng nga nidako ka, no? So, kung niwang ka, for example, ang imong unang state is niwang, okay mo na imong state 1, nikaon ka, ug dako, pero ni-exercise ka og gamay, and ni-exercise ka og gamay, so posible nga mo change imong internal energy to tambok. So na-increasing mong internal energy, meaning nagkatambo ka. If your system is your body. Okay? Nakuha. If your system is your body. So from state 1 nga niwang, nikaon pagdaghan, na-exercise ka gamay, ni-change imong internal energy, ni-change imong state. Since ni-change imong internal energy, nag-change imong state from niwang to tambo. And then kung balik po ang process, magpaniwang ka for example, kung sa ibato nimo, magpaniwang ka, ipagamay nimo ang delta U, okay, decreasing ang U, i-decrease nimo ang U. So sa imong buhaton, mas dako ka workout dapat kaysa kaon. So muna ang meaning, no? Mas dako ka og exercise dapat kaysa sa imong kaon. So that is why mag-diet ka, gamay ra ka kaunon, tapos mag-gym ka for example, para ma-change imong state from tambok to niwang. And tambok to niwang, it means na ga-decrease imong internal energy. Okay? Ga-decrease imong internal energy. So ingana lang ang first law of thermodynamics. Ingana lang ka simple, kulang taon nimo, no? Kung gusto ka magpaniwang, kinahanglan ka mo exercise o gamay ka kaon. Kung gusto ka magpatambok, sige ka kaon, i-take ka og heat. Take ka og heat pero wala kay work, wala kay exercise, wala. So 9 times na mo change din imong state, then magkatambok din imong lawas. Okay? So that's first law of thermodynamics. Okay, so muna decreasing, no? Decreasing kay katong ningo, no? From tambok to niwang, for example. Tambok to niwang. So, ang magbuhaton kay work, remove kag heat sa mulawas. Ang work done is on the system. So, na negative na change of internal energy. Okay, so that's first law of thermodynamics. In a thermodynamic process, the internal energy of a system may remain the same. Ano sa mo the same kung ang work done by the system is just equal to the heat added or heat enters the system. So equal lang silang duha. So kapag chocolate tapos nag-exercise ka para mawala tong mga energy, para mawala tong heat na na-add sa imong system, then walay na-change sa imong internal energy. So muna yung ginabuhat sa uban, no? Para niwang yan po sila, wala nag-change ilahang state, wala changes sa iyang internal energy. Pag mukaon sila, kaya mo exercise sila equal sa ilahang ikaon. So that's the meaning of internal energy equal to 0. Okay, so this is the first law of exercise thermodynamics. So muna kong gingon your body is pwede na ako i-consider as a thermodynamic system. And ang first law, ma-apply nimo ang first law of thermodynamics by this exercising. So when you do push up, your body does work. Therefore, your work is positive because ang system mo nagdaan sa work. The work is positive. Your body also warms up during exercise, and by perspiration and other means, the body rids itself of this heat. So basically, kung mag-exercise ka, panington ka, then ma-remove na heat sa imong lawas. So therefore, your Q is negative. So therefore, the internal energy will decrease. Since Q is negative and W is positive, and using first law of thermodynamics, your internal energy will decrease. That's why exercise helps you lose weight and it uses up some of the internal energy stored in your body in the form of fat. So that first law of thermodynamics uh, na application sa atong body. So please use wisely the first law of thermodynamics. So exercising or what. Kaya pwede mag-run to siya ang mga abutan, no? Like kauntar daghan and so on. Okay? So there are two special cases of first law. We have the cyclic process and the isolated system. For the cyclic process, you have to take note that when kung cyclic process, your internal energy, the change of internal energy is equal to zero. It means na kung internal energy ni mo kay change of internal energy is zero, it means na your final internal energy must be equal to the initial internal energy. So meaning ani, kung imong initial, kung imong thermodynamic system is imong body, for example, ang cyclic process kay kung niwang ka, pagkauma natulog ka, niwang magyapon ka, wala na change ang imong state, no? Wala man nag-change imong internal energy. So cyclic process kay balik ka sa imong original state. So, for example, na kung state 1 pa ka, dagan ka gibuhat, nag-do ka work, nag-add ka heat, and so on. Pero, at the end of the day, cyclic process means, at the end of the day, ibalik ka gihapon ka sa imong initial na state. That is cyclic process. So, it means na, your delta U is equal to 0. And using first law, it implies that the heat added is equal to the work done by the system. So, muna ang kaning, for example, na taong dili manambok, dili mo change ang iyang state, dili mo change ang iyang lawas, kay although nag-add siya og heat, pero nagduman po siya og work. So, kung equal ang heat added sa iyang work done, then we call that one a cyclic process. Okay? So this is the cyclic thermodynamic process for a human day. So muna no, nikaon siya kaning mga yellow nga araw, muna ang heat added. Okay, i-total nimo na, that is around 16.5 times 10 to the 6 joules. So nagkaon siya, pero nagdumong po siya work kaning mga pula nga araw. So nagado siya work, exercise, studying, watching TV. 4 hours nga watching TV, studying ng mga 1 minute. So, nasa work nga na. Sleeping, napupoy work nga na. Work done by your body. If you add that, all this work, you'll get 16.5 times 10 to the 6. And Q is equal to W. So, therefore, delta U is 0. So, we call this one a cyclic process. Wala nag-change ang imong internal energy. Okay? Wala nag-change yung mga internal energy. Equal lang ang work ug ang heat added. So wala ang dili siya namin nga 0 po diyang work, 0 po diyang heat. Equal ang duha para makaingon ka nga cyclic process, para makaingon ka nga change, wala change in internal energy. Next is we have isolated system, one that does no work on its surroundings and has no heat flow from its surroundings. It means na it implies that the Q, or it means na your Q and W is equal to 0. Walay na isolated kay di nimo apilang surroundings. Walay apilang surroundings, walay na add nga heat, walay na remove nga heat from the surroundings, and wala po'y work na nadan. Okay? Wala po kay work na nabuhat. So that is, we call that one as isolated system. So work 0, heat 0, therefore delta U is also equal to 0. The internal energy of an isolated system is constant because there is no change in U. So that's isolated system. So we have two special cases of first law, the cyclic process and the isolated system. Okay? Okay, for example, you propose to climb several flights of stairs to work off the energy you took in by eating a 900 calorie hot fudge sundae. How high must you climb? Assume that your mass is 60 kilograms. So we will use now the first law of thermodynamics to solve how high must you climb para mawala ang energy nga ni-enter sa imong system. Okay? So, ang goal ani is kinahanglan ka mag-workout. Since nagkaon ka og Sunday, kinahanglan nimo sa exercise para dili mag-change imong internal energy. So basically, nikaon kang Sunday pero dili ka gusto manambok. Nikaon ka og hot fudge Sunday pero dili ka gusto manambok. That is why nagbuhat ka or nag-do ka work sa imong lawas. Okay? So, it means na if you use first law of thermodynamics here, you have delta U solution, which is equal to the heat added minus the work done. And kumingkog to work off the energy you took in by eating this sundae, it means na your change of internal energy is equal to 0. Kay dili ka gusto mag-change ang imong state. Dili ka gusto mag-change imong internal energy. We also call this one a cyclic process. So it means na if delta U is 0, then it means na your work is equal to the heat. And unsa nga heat ang nadari? It is the energy na ni-enter sa imong system, which is equal to this 900. Take note that kumingkog 900 food calorie. If you convert this to calories, this is equal to 900 kilocalorie. Take note of that. 1 food calorie is equal to 1 kilocalorie or 1000 calories. So therefore, we will use Q equal to 900 kilocalorie for the calculations. Okay? And you also need to, since heat, the unit of heat is joule, you also need to convert calorie into joule. So ito, ang iyahang conversion. 1 kilocalorie is equal to 4186 joules. So therefore, my Q is equal to multiply this na ko 3.77 times 10 to the 6 joules. So this will be the heat added in the system. So muna ako ang Q. Okay? We know now Q, but we don't know W. Kung saan work ang na-assign ng system. We have to take note that work, okay? Work is just the dot product of force and displacement, okay? And ang force nga naalang sa imong system since isa ka pataas, again since ni climb ka sa pataas, then ang force lang na nadiri is only the gravitational force. And we know gravitational force. Your force is just mass times gravity, and the distance is kaning height h. So this will be my work. Work is equal to mg times h. Equating these two, which is equal to mgh equal to 3.77 times 10 to the 6 joule. So my h, how high must you climb? So akong kuhaan is ang unsa sa kataas ng saka is equal to 3.77 times 10 to the 6 joule over mass nga 60 kilograms times g nga 9.8 meters per second square. So h here is around 6,410 meters. Next, this is a cyclic process. Figure, it shows a PV diagram for a cyclic process in which the initial and final state of some thermodynamic system are the same. Okay? As shown, the state of the system starts at point A. So this is my initial state. Okay, point A. And proceed counterclockwise in the PV diagram to point B, then back to A. And the total work is negative 500 joules. Question: why, for letter A, no? Why is the work negative? So, anong negative man ang work? We have to take note na si work kay pwede man 0, pwede man positive, pwede man negative. Okay? And tanawin mo ang path niya, gikan sa A, counterclockwise, padulong sa B, then ibalik siya sa A. Cyclic siya kay nibalik man siya sa iyang initial nga state. Question is, nganong negative siya? Of course, nganong negative gali siya kay, take note, ang work done from A to B is positive. Sa kuha? the work done from A to B is positive. Why? Because your volume increases. Tama? So therefore, the work done here, kani, work done from A to B is kani akong gisidan. Okay? Work done from A to B is muna akong gisidan. And then, the work done from B to A, take note, nasa sa taas. Okay? And the volume decreases. Okay? Pag decrease ang iyang volume, so it means na ang work done there is negative. Tawa? And notice, the work done na positive is mas gamay siya sa work done na negative. So that is why your work is negative. That is why your work is negative. So since mas dako ang work done nga negative, kaning dito mas dako man siya area nga na-cover, tatwa? Mas dako siya area nga na-cover compared to the area nga na-cover diri sa ubos. So kani siya kay negative, then plus positive dari na mabilin gamay nga area dari. This is 500, negative 500 joule. Okay? Negative kay, take note, mas dako og area nga na-cover ang path from B to A. Okay? So that is why negative ang imong work. Find the change of internal energy. For letter B, find the change of internal energy. So what is delta U and what is heat added? It's very simple. Since this is a cyclic process, then delta U is automatically equal to 0. Okay? And from first law of thermodynamics, delta U equals Q minus W. This one is 0, so therefore Q is W. And W is given, this is equal to minus 500 joule, so therefore heat added is also equal to minus 500. Another example, so we have this for PV diagram. It shows a series of thermodynamic processes. And given in process AB, among process AB, ano gani? Change na itong color. Yellow lang. So process AB, here, given process AB nga heat equal to 150 joule. Okay? And then in process BD sa taas, given na heat here is equal to 600 joule. Okay? So take note of that. I'll change some colors. Okay. Heat here is 150 joules. Heat here is 600 joules. Okay? So mura nang given, no? In process AB, kaning arrow dra. Okay? In process AB, 150 ang heat added. In process BD, 600 joules of energy ang na-add. Question. Find the internal energy change in process AB. Okay? For letter A, find the internal energy in process AB. So akong paon is in the process AB. So paning part dari. Okay? So paning part dari. And we know first law of thermodynamics is equal to the change of internal energy AB. Process AB is equal to heat added in the process AB minus work added in the process AB. Okay? And we know QAB. QAB is equal to 150 joules. Degree. QAB is equal to 150 joules. And we also know work. Work AB is equal to 0. Why? Anong 0 si work AB? Because sa process AB, there is no change in volume. Sakto ba? Ang nag-change lang sa process AB is only the pressure, but the volume ang volume niya the same lang. So therefore, work done in the process AB is 0. So therefore, the change of internal energy of AB is just equal to QAB, which is given. This is equal to 150. Very simple. Okay? That is for letter A. How about for letter B? So sa letter B, find the change Find the change of internal energy in process ABD. So, ang ipangita na po na to is ang delta U sa ABD. So, among ABD ani, kaning, dari, this one, this is AB, and then this is BD. So, ang kaning green one, muna ako ang process ABD. So, muna ako ang process ABD. So, aha ka ni pass ni Agi. Ako gikan ka dire padulong sa B, tapos padulong sa B, gikan sa B padulong sa. That is for letter B. So, sa akong kuhaon, for letter B, the delta U of process A, B, E. Asa ka niagi nga path? Niagi ka sa taas nga path. Okay? So, niagi ka din sa taas nga path. And using first law, this is equal to Q, A, B, D, minus the work done sa process nga A, B, D. Mag-zero ba ang ABD? Yes or no? No, because the ABD kay na ako'y work done from B to D because your volume, ang volume nimo kay nag-change man. Therefore, walay mag-zero aning tulong nga term. Okay? Okay. So, to solve for this, kinahanglan na kukuhaon si QABD and si WABD. What is QABD? QABD is just the heat added from the process AB plus the heat added from the process BD. Sakto ba? And we know this one. The heat added AB plus the heat added BD is just equal to QABD. Okay? Nakuha. Okay? So, this is equal to, this is given, 150 joules plus QBD nga 600 joules of energy. So, QABD is equal to 750 joules. Okay? So, that is QABD equal to 750 joules of energy. Now, next thing to do is to solve for the work ABD. Work ABD is equal to this. Work ABD equal to the work done sa AB nga process plus work done sa BD nga process. And we know work done sa kaning AB, kaya wala mo nag-change ang volume, this is equal to 0. And the work done sa BD, take note sa BD ha, kani? Aha, sa work done sa BD, your pressure is constant. At constant pressure, the work done is just equal to pressure times the volume change V2, BD minus BD. Aba? The volume at point D minus the volume at point B. Okay? And we know this one. Na ako'y pressure nga, this one, 8 times 10 to the 4, pressure is 8.0 times 10 to the 4 pascals, multiplied by the volume VD. Una akong volume VD, no? 5 times 10 to the minus 3 meters cubed minus the volume VB is equal to this one. Okay, this is 2 times 10 to the minus 3 meter cubed. Multiply this one, you will get work done ABD is around 240 joules. So this is 240 joules of energy. So therefore, thus, the change in internal energy in the process ABD is around, kailangan ako ang heat is equal to 750 joules minus work na 240 joules. So the delta U of ABD is equal to 510 joules. Okay, let's now go to letter C. The total heat added in the process ACD. So ang ipangita sa letter C is the total heat added in the process ACD. Okay? The total heat added in the process ACD. So meaning, niagi ka, wala ka niagi dire sa taas. Okay? Kaya niagi ka dire sa ubos na pa. Okay? Niagi ka dire sa ubos na pa. A, C, and D. We know that the internal energy here sa taas, take note na, nakuha na to ng internal energy sa taas, delta U, A, B, D, this is equal to 510 joules. Okay? So what is QACD? Very simple. You will use first law of thermodynamics. Na po, delta U of ACD is equal to heat ACD minus work ACD. So therefore, Q ACD is just equal to delta U ACD plus the work done ACD. First, isolve mo sana ko si delta U ACD. This is equal to 510 joules. Why? Why? We have to take note na si change of internal energy kay independent siya sa path. Ito ba? Bitag asa siya moagi. Take note sa kaning path. Sa kaning path, bitag diri siya moagi or diri siya moagi sa ubos, okay? Same lang dapat ang iyang internal energy. Kaya ang point naman ani kay sa internal energy is pila ang energy from point A to point D, from initial state A to final point D. So bisag asa nga path, dapat same lang ang imong delta U. And we know that the change of energy here sa taas is 510 joules. So therefore, ang internal energy change sa imong sa ubos pod nga path, kay same raman sila og final nga path as final nga state, same lang dapat siya og change of internal energy. So therefore, your delta U ACD is also 510 joules because equal lang siya sa delta U sa ABD. Ano kay ito? Kay ang change of internal energy independent siya sa path. Okay, path and independent. Okay? Path independent. So nakuha na ko si delta U, masolve ko na ko si WACD, and sa matapag-solve sa WACD, ako WACD equals WAC plus WCD. This one is 0. Okay? Sa CD nga part ng process, your volume is constant, so therefore work done is 0 at that point. So at this kaning CD nga process, your work CD is 0. So ang naalang is kaning work done from point A to point C. Constant pressure, so na ko'y P times the volume C at point C minus volume at point A. So pila ni siya? It is equal to 3 times 10. 3 times 10 to the 4 times 5 times 10 to the minus 3 meters cubed minus 2 times 10 to the minus 3 meters cubed. And that is equal to 90 joules of energy. So QACD is equal to delta U ACD plus work ACD. So we have this is equal to 510 joules plus work done na 90 joules. So therefore the total heat added in process ACD is around 600 joules. So this will be the heat added in process ACD.